Array-based snaps and clones bring the usual hardware offloads to the party. These include offloading the burden of snap and clone creation and management away from the CPU, RAM, and network of the host. Array-based snaps and clones also allow snaps and clones to be mounted by hosts other than the host that the snap or clone was taken on. And this can be really useful for things like mounting copies of a production database to other hosts for research and for test and dev requirements, or maybe mounting them to a backup media server so that they can be copied off to tape quickly and without impacting the performance of the source volume. Array-based snapshots and clones are also fast. They're created instantly, and generally speaking, they're high performance due to the nature of the storage array. However, they can cost a lot of money, and often, but not always, they need to be licensed on the array. They're also scalable. Many array-based snap and clone technologies allow for hundreds of snaps and clones to be created, often of a single source volume. They can also be integrated with array-based replication technologies, allowing for situations where snapshot or clone volumes can then be replicated to remote sites, or alternatively, situations where snaps and clones are taken at remote sites, with their source volumes being the remote end of a remote replication pair. So you may replicate a volume to another site, and then that replicated volume at the other site can be used as a source volume for snaps and clones. And these kinds of configurations are common. Now, last but by no means least on the topic of array-based snaps and clones, in their vanilla form, array-based snaps and clones are at best crash consistent. So a couple of terms I think to define there. By referring to snaps and clones in their vanilla form, we mean just using the native snap and clone technology of the array. No additional agent software on the host to help integrate the array-based snap and clone technologies with the host and application technologies that they're taking snapshots of. So just using the array snap and clone technologies without the host and application knowing that snaps and clones are being created. And for crash consistent, this is an awful term. It basically means that your data could be totally inconsistent. Crash consistent is only as consistent as you might expect an application or an operating system to be following a crash. And like we said, that could be insanely inconsistent. In the extreme cases, your snap or clone might be in such an inconsistent state as to be unusable. Whereas in less extreme cases, it may require a load of log replaying to be fixed and to be made consistent. Either way, you definitely don't want to have to rely on a crash consistent snap or clone in the event of a disaster. So, in their vanilla form, array-based snap and clone technologies create hideous crash consistent copies of your application data. They may work as a recovery vehicle, or they may not. It's like playing Russian roulette with your application recovery plans. Don't play it. Fortunately though, array-based snap and clone technologies can work hand in hand with applications, so that the snaps and clones they create are application consistent. And let's talk a bit about that before we wrap up the lesson.